Okay, let's have a look here. Use the following graph to evaluate f derivative at 1 and at 6. Okay, so at 1, it's going to be a straight line, so it's going to be a rise over run, but it's quite hard to see. I'm going to say f derivative 1 is roughly equal to 5 over 4. And f derivative 6, that's a little bit easier. It's going to roughly equal 2. Oh, 6. 6 is here, yeah. 2 over 4, which is a half. Oh, well, that's easy. That's 0. And then 1.5. Well, is it defined at 1.5 or is the graph just cut off? That's really tough to see. It's not even quite in the middle. It's like a quarter over a quarter? No, I mean 1 over a quarter, roughly equal to 4? Or maybe a quarter is too much. Maybe it's more like a third, so 1 over a third, so 3 maybe. Let's check the answers. 39 and 40. 1.25 and 0.5. Excellent. But no answers for the next one, of course. I have to assume it continues, by the way. All right. Let's continue. Right, so that's 39 and 40. For following exercise, use the limit definition of derivative to show that derivative does not exist at x equal a for each of the following functions. Okay. Let's grab these and paste. Okay. For the following exercise, use the limit definition of derivative to show that the derivative does not exist at x equal a for each of the given functions. Interesting. Wonder how formal we need to be in this answer. You see, in 41, for example, the derivative will equal the limit as h tends to 0, and it will be 0 plus h cube root minus 0 cube root all over h. So that's the limit as h tends to 0 of h cubed over h. That's equal to the limit as h tends to 0, h minus 2 over 3, which is the limit as h tends to 0 of 1 over cube root h squared, which does not doesn't exist we can't, I mean, it's going to diverge. Basically, it's going to become infinite. There's an infinite discontinuity at h tending to 0. So that's interesting. That's interesting. I think if I picture the graph of the cube root function, it must be like quite vertical at the origin. That must be what's going on here. I suspect the answer at the back says something like that. Let's see what it says for 41. Yeah. Yeah, infinite. Okay, so I think we're doing this the right way then. All right, next one now, 42. Well, it's pretty much going to be the same thing, isn't it? The limit as h tends to 0 of h power 2/3 minus 0 over h, and that will equal the limit of h power minus 1/3, h goes to 0, which is the limit as h goes to 0 of 1 over cube root h. And in this case, the limit as h tends to 0 from the right will tend to plus infinity, and the limit as h tends to 0 from the left will tend to minus infinity. So we don't have a limit here. Okay. Okay. Right. That seems very similar to a little different, but quite similar. Okay. 43. Yeah, it's the same problem. The right and left limits aren't defined. So the limit as h tends to 1 from the right, then what will happen here is x for f of x. So that will be 1 plus h minus 1 over h, which is equal to 1. And then the limit as h tends to 1 from the left will be 1 minus 1 over h, which is 0. So that means there does not exist a limit as h tends to 1 of f of 1 plus h minus f of 1 over h. So I assume it's going to say that at the back as well. Um, 43. Yeah, you get 0 for the minus answer, and then which doesn't equal 1, and then weirdly they didn't put in. Oh yeah, 0, and that doesn't equal 1. Yeah, okay. Okay, that's fine. Okay, let's have a look now at the last one here, 44. Again, I think it's going to be the same problem. The left and right limits aren't defined. So the limit as h tends to 0 from the right that will be that'll be positive 1 minus, and then oh, it's not even defined actually at 0. So we can't we don't even have this 0 plus h minus f of 0 over h, since it does not exist an f of 0, because we're not like, because we'll have 0 over 0, so we can't calculate this, because we can't calculate f of 0, and we can't even make it continuous at f of 0 by looking at the limit, because it's actually worse, because there does not exist a limit as x tends to 0 of absolute x over x. So yeah, no hope here. Okay, good. Let's see, you're still recording? Yeah. All right, that's those few. Technology question now. Back to the spreadsheet, it looks like. Looks like it. The position and feet of a race car along a straight track after t seconds is modeled by that function. Find the average velocity of the vehicle over the following time intervals and draw the conclusion about the instantaneous. Very similar to the ones earlier, so I don't know why they're grouped separately. So let's have a look here. Okay, so this one, it is 4, and then the h is the usual 0.1, 0.01, 0.001, and then 0.0001, and oh, actually this one's a little bit different than the one earlier. Yeah, it's a little bit different. So what I'll do, I'll make a new sheet. Yeah, we have to calculate the derivative st. Yeah, okay, so we'll have time t1 and t2, and it's 4 and 4.01. No, 4.1. Well, let's make this a bit more precise. It's equal to 4 plus 0.1. Okay, and that's O, 2 O's, 3 O's. Doesn't say anything about decimal places this time. And then we'll calculate S of T2, S of T1. So S is 8t squared minus t cubed over 16. So that's 8t squared minus t cubed over 18. 16. T squared. Okay, and then would have been better if I had these the other way around to match up with this. Because then I can copy and paste it more easily. So I'll change this to ST1. just the ST2. Instead of B, I'll make it A. So these should all be the same, and then these ones should be different. And then the velocity will equal this minus this. Oh, it looks like it's slowing down. Over this minus this. Did they want the velocity or the speed? Velocity. And just remember, these are meters per second. No. Oh, was the one earlier meters per second? Yeah, it was. This one is feet per second. Estimate, looking like it's minus 61 feet per second, I should say. Okay, that answer should definitely be right at the back. Where is it now? Yeah. Oh, but they're all positive. So maybe I mistyped it in. Ah, I did mistype it. B minus C, or it's C minus D. 61. Yeah. But it doesn't say anything about rounding, so I have more decimal places than they do. Okay. Same again now. 14t squared. Find the average velocity and infer the instantaneous velocity. That's 14t squared. Okay. Okay, it looks like it's going to 112. The answer for that one. Oh, no, and it's 5. Okay, so it looks like... Oh, funny. Still 112. Oh, no, what am I saying? No, I have to change this one. 140. Okay. 140. Yeah, that's right. Ah, this is distance, but it's also displacement because it can't be negative really since the ball is rolling down an inclined hill. So unlike a car, it won't decelerate and roll backwards. So I would have preferred this to say speed, since it was distance. Is it worth opening the ticket about? No, maybe not. Okay. How are we doing for time? Maybe we should wrap it up here. Maybe we'll just finish on 47, and then that's the end of the page. And then that leaves us with one page left, half a page. Okay. Right. Two vehicles start out traveling side by side along a straight road. Their position function shown in the following graph is given by S is F, S is G. Okay. Which vehicle has traveled farther at 2 seconds? So at 2 seconds, The blue one, the F one, because at 2 seconds, the F is 2, or the units here, feet away, whereas the G one is 1 foot away. What is the approximate velocity of each vehicle at t equals 3 seconds? Okay. So that's basically F derivative 3. Well, that's a nice 45-degree one. So that's 1 foot per second. A little bit tougher now will be G derivative 3. No. Not bad. Okay. Let's get the rise and the run here. Roughly equal to 7/5, which is roughly equal to 1.4 feet per second. Okay, C. Which vehicle is traveling fastest at t equals 4? G, since you can see that the slope of the tangent at 4 is greater than for G than it is for F. What is true about the position of the vehicles at t equals 4? They're side by side. They're together because they have the same position. Okay. Right. Let's check the answer out. Hopefully we are right. 47. Vehicles represented by F. Correct. And it's what I said, 2 versus 1. The velocity of t is a 1, while g is approximately 2. 2. Okay. That's a poor reading from the graph for me. I don't know. I thought it looked pretty tangential when I drew it. But I guess it's steeper. Should be 2. Okay. The vehicle represented by G. Yep. And both have reached 4, so they're both side by side. They're caught up to each other. Okay. Actually, if you want to be more precise, G is about to overtake F. Okay. That's good. And that leaves us with tech questions. We should hopefully get this finished the next time. That looks like another spreadsheet question. And we'll have to make some graphs for estimating. Yeah. Okay. Yeah, okay, so we're coming to the end of this exercise. I know I've used the word derivative, but I think derivative comes up more Oh no, they do use it in this section. Okay, so it's not a new word then that you haven't seen yet. Okay, so we'll leave it for there for today. We got a bit done, and I'm less tired today, so less mistakes than yesterday. Thanks for watching, and I'll see you all next time.